Right. So in the previous class, we saw there are two main device type in networking. One is switching, the other one is routing. The router and the switch. These are the two main functions. There are other features, as I said, like firewall, but they also depend on routing and switching. So basically, you need to move the packet from one part of the network to the other part. Geographically, they may be very far away or they may be local. But to move the packet, these are the two things. Moving the packet within the devices that are in same network, between the devices that are in same network, moving the packet between the devices that are in different network. These are the two things. Same network we call switching and we need only switches. Between different network we call it as routing and we need routers. Now what is next? We also need to know the ancient devices. I can say ancient devices. The reason is it's no more in use. The first one is amplifier. In the beginning, the amplifiers were used to amplify the signal. As the signal becomes weaker when they pass through a media for a long distance, this media cannot carry for a very long distance. The Ethernet cables or the serial cables or the fiber optics cable, everything has got a limit. In those days, no fiber optics. There were only coaxial cables. Like early days in India, we used to have a cable TV. That cable TV wire which you have at the backside with one copper wire with a shield, we called as coaxial cable. That's the type of wire we used to have for communication, and that has got limitation. Even you might have seen on the olden days, the cable operators used to have boosters. That is what here also we have, amplifier to boost the signal. The amplifier will boost the weakening signal. As the signal travels, it becomes weaker. It needs to be boosted up so that it can go again for another long distance. Amplifier were introduced, but there was also a problem when we use amplifier. What is it? It also amplified the noise that gets added in the path. The noise was also amplified. Noise is not the actual data, but the data that gets created because of electromagnetic force or the geo force like gravity force. They are all added in the path, and when it goes through the amplifier even amplifies those noise along with the data. So when the receiver receives, he is not only just reading the document that is sent, he is also reading the data mixed with noise. He is also seeing some symbols, some letters which is not really expected there. These are all noise. These are all not the actual data sent. These data are created because of magnetic forces, the electric force on the roadside, the transformers and so on, the magnetic force. So amplifier was refined and that refined device now amplifies or regenerates only the signal, actual data. We call that as a repeater. So repeater only regenerates data. It can easily identify which one is data and which one is noise, and filter the noise and repeat or regenerate only the data. Good job. And then the network started growing. Not just two devices, we want to connect more devices. Then repeater is not sufficient enough. Why? Repeater will have only two ports. Only two ports. So a multi-port repeater was designed. See, it is a repeater which will regenerate only the data by filtering the noise, only the data by filtering the noise, with an advantage of more ports. And this is what we call it as hub. Hub is a multi-port repeater. Hub is a repeater with more ports. But we don't call it as repeater, we call it as hub. Now, hub, repeater, amplifier, these three are not in use. The reason is these three devices are dumb devices. Dumb devices. Dumb devices. When I say dumb devices, I recall this. Put some salt in the sambar. Okay, I put. Check whether you see a salt. You see salt. No. Okay, then put more until you see the salt. And this fellow finished putting the entire box of salt, maybe 2 kg of salt in sambar, and still he says, I don't see salt. I don't see salt. That dumb. Salt should be seen by tasting. But this fellow do not know even those basic stuff. He's looking for salt through his eyes. He cannot see even if he put 100 kg of salt there inside the sambar. That dumb is this three device, amplifier, repeater and hub. Why? This never learns MAC address. This cannot see who is connected where. Because it cannot see who is connected where, for every destination, it has to send the packet to everyone. For example, if A wants to talk to B, when the traffic hits the spot, hub will send it not only to B, also to everyone. Because hub never learns who is connected where. Repeater and amplifier also the same. They don't learn the MAC address of connected device. They don't maintain MAC table. We saw in the previous class, switches maintains MAC table. They maintain MAC table. So switches can send to the right person. If A is sending to B, the traffic will go only to B. The traffic will enter into this port and only leave this port. Because the switch knows which computer is connected on which port. It learns the MAC address against the port and maintains it in the MAC table. So we call switch and a bridge as a intelligent device. Switch and bridge both are learning MAC address and maintaining MAC table. But why we don't use bridge, I told you that also in the previous class, but I want to repeat again. Bridge, why do we don't use bridge today? Though it is a intelligent device, it is not for a large scale environment. Bridges cannot handle large amount of traffic. Bridges or software based device, they don't have too many hardware components to handle more traffic. It's only the operating system. It's only the operating system that needs to be responsible for all activities in packet forwarding. So the software cannot handle too much. Whereas the switches are hardware-based device, along with the operating system, switches got more chipsets, more ASIC chip, which can share the load of traffic. So switches are widely seen today because we have big network environment. Millions of packets are processed per second from many devices, so bridges can't handle such huge amount of traffic. So we have hardware based device, switch. See, for the look, it looks the same. The physical box, bridge and switch will look the same, but bridge has got the motherboard and one operating system, and the operating system takes the complete load of decision making, packet forwarding. Whereas in the switch on the motherboard, you got more hardware, additional chips, additional hardware with the operating system. So extra processors, ASIC chips or extra processors, that makes the switch to support more traffic. So for a large environment, we need a hardware based device. That's why we have switch. So switches maintains MAC table, so there is no need for broadcasting the traffic all the time. Hub never learns MAC address, so they broadcast all the time. That's why we don't go with hub. We don't go with hub. We have switch, we have routers. Now, we need to understand two terminology. Number one, collision domain. And broadcast domain. Collision domain and broadcast domain. These two are very important to understand. Should know these differences. In later levels, expert levels, the knowledge of collision domain and broadcast domain is very important. Right from the beginning, we should know these things. Only then we'll be successful in networking. Collusion. We know what is collusion. When there is too much of traffic, when there is no room to accommodate, packets collide each other. We know what is broadcast. Sending to any. We do not know to whom it is going, but we are sending. Broadcast domain. Sending to any, not many, any. You do not know. So any. That's broadcast. Now, the domain, the word domain, if you understand along with this, then you will know these two topics very well. Domain, the kingdom, king's dominion. The area which is under the control of a king is a kingdom. Under the control. Collusion controller. Broadcast controller. Collusion domain means what? Collusion controller. We know what is collusion, but to control the collusion, you need a controller so that you won't have a collusion. Broadcast controller controls the broadcast. It should not go and disturb everyone. For example, there is a residential area, and there is one temple. Now, in the residential area, some may be sick, some may be in a different family situation, sad, some are happy. So, during the festival time, I have seen in some villages, they keep the horn very loud. They make a very big noise, sound, thinking that God is being pleased when they keep the song very high. What song? Appadi podu, appadi podu. How will God be pleased when you play that song appadi podu, loudly? And everyone in the surrounding getting disturbed. Some may be preparing for exam. See, the broadcast need to be controlled in that area. Let them have the song, but that cannot go and disturb the others, because others are not in the same mood as these people are. So to control the broadcast, what they do, the sound PA system guy, he goes and reduces the volume. That's a broadcast controller, so that it won't go to the next village and disturb them. It can be controlled, that the distance to which the broadcast will go can be controlled. Likewise, in networking, we have broadcast controller, which means that controller won't allow the broadcast to go further. If there is a controller to control the broadcast, what it will do? It will stop the broadcast right there. The broadcast is coming from very far. As soon as it comes close to the controller will say, okay, fine, I'm happy that you came this far, but enough. You don't move to the other side. Stop here. That type of controller is what called as broadcast controller. For example, I have a computer with 10001, 10002, 3. Let's say I have a router. This interface of the router will also have 10.0.0 only. Let's say 4. So this represents the device ID and this represents the network. 10 is a network in that first computer, second, third and fourth device. So devices are identified with this address, this IP address. This IP address or logical address. Why I call IP address as logical address? Because you have MAC address, which is physical address. MAC address is physical address. IP address is logical. Meaning IP address can be changed time to time. For example, when you are using your cell phone in your home network will give you an IP address. When you take your cell phone outside, your home network is no more. You are connected to the data, the SIM card company. They provide IP address. And when you go to office, your cell phone connects to the office Wi-Fi, that gives another IP address. So what I'm saying is IP address changes. IP address changes. MAC addresses, they never change. They are hard-coded, burnt-in address. That's why we call IP address as logical, because it changes. Okay, we got these three computers and a router and an address to identify. This is one LAN, local area network. I'll call it as LAN 1. Now I got another LAN with 20.0.0.1, 20.0.0.2 and a switch to connect them. And I connect to a router so that I connect to LAN 1. This is LAN 2. This is how we draw a router, one round and one X. Switch we just put like this rectangle. If you have more time, you can also do like this. Not needed actually, no need to do like this. So just put one rectangle for a switch and one round for a router. Now this is another LAN. 2 LANs we have. Now when a broadcast is sent, there is a controller stopping here. Hey, stop here. Why? The broadcast that is coming from 10.0.0.1 should go only to the members of the same network. 10.0.0.2, 3, 4. Why it should go to 20.0.0.3? Not necessary, no? So the routers have got broadcast domain, broadcast controller. Every port on a router will have a broadcast domain. For example, if there is a broadcast coming from here, it will go here, it will go even here, but it won't go through the router. It won't go through the router. Router will stop. You are not allowed to pass through. Why? Because routers, every port has got a broadcast domain. If I have 5 ports on a router, in a router, each port have got one broadcast domain. So totally how many broadcast domain? 5. 5 broadcast domains. So when a broadcast is sent, it is sent only to the members of same local area network, same LAN. Routers won't allow the broadcast to go to the entire world. That is a disturbance. I told you, no? When a song Appadi Podi Ipadi Podi is sung in a temple, why it should go and disturb some people who are studying, who are in a different mode, who are sick, who are having some depression? That's not good. Likewise, the broadcast of one LAN should be within that LAN. That's why every port on a router has got a broadcast domain, so that from this LAN the broadcast won't go to the other LAN to disturb them. It's unnecessary. Routers are the only one which connects different network. So if you have each port with a broadcast domain, then you can easily control the broadcast of each LAN then and there itself. Any broadcast packet that is coming to the switch will not stop. Switch will send it to every port. The reason is, for one switch there is one broadcast domain. What does that mean? One broadcast domain for one switch, which means all the ports of the switch are in one group, one LAN, one group. That is why when a broadcast comes from one computer, it can go to every computer in that LAN because they're all in one broadcast domain. They're all in one group, one broadcast domain. So even it comes up to here, but the router will not allow to pass through because this is in another broadcast domain. For this one entire LAN, how many broadcast domain? Only one. How many broadcast domain here? Another one. Two broadcast domain. Even when I don't have a router, how many broadcast domain? One switch, one broadcast domain. This is another switch, so this is another broadcast domain. Now when I have, so totally two broadcast domain, but two are two separate broadcast domain. When I have a router in the middle, still it's two broadcast domain only. Because the broadcast of this LAN ends here, broadcast of this LAN ends here. When you don't have a router also, broadcast cannot go because they are not connected. They are not connected. So again, it's two broadcast domain. Even if you have a router, they are not going to go to the other side because routers are not going to allow any broadcast to pass through. The reason is every port has got a broadcast controller, broadcast domain. Not only that, a router also got collision controller. So each port of a router will have one collision controller, one broadcast controller, broadcast domain, collision domain. Collision domain and broadcast domain. If I have two ports in a router, how many collision domain? Two collision domain and two broadcast domain. So that's about the router. Routers have got collision domain and broadcast domain on each port. Anything that controls the collision is a control, it's a collision domain. For example, if you take a switch and a hub, hub will never learn MAC address, and a hub has got only one broadcast domain and one collision domain. What does that mean? When these four devices send traffic, because hub do not know where is who connected, who is where, because they don't learn MAC address, it will be always broadcasting. Whereas in the switch, they learn MAC address of the device. Let's say this is port number 1, port number 2. Switches maintain MAC table. Yeah, so you see it maintains a MAC table. It knows who is where. That's why we call a number of collision domains. Say for example, if the switch is 24 port, each port will have a collision domain. Why? Why do we call each port with a collision domain? Why do you call it as 24 collision domain? Because each port can learn the MAC address. As a result, they no need to flood and cause collusion. They avoid collusion by learning MAC address, isn't it? Because they learn MAC address, because they know where is who, it avoids collusion. I said collision domain, collision controller. Yeah. So you got 24 collision domain because they learn MAC address of each port. Whereas here only one collision domain, meaning there is only one logical backbone. You might have learned bus topology. Inside there is a logical bus that is the only one responsible to control the broadcast as well as the collusion. Whereas here, whenever you need broadcast, you have one broadcast domain. I told you in the previous scenario there is one broadcast domain in a LAN, so that if a broadcast is sent from A, it can go to everyone. There is one broadcast domain in a switch and n number of collision domain, where n stands for number of ports. If I have 48 port switch, then I'll have 48 collision domain. How many broadcast domain? Only one. Switch will have only one broadcast domain by default. By default, one broadcast domain, and collision domain, it depends on the number of ports. Whereas hub will have only one collision domain and one broadcast domain. And the router, each port will have a collision domain and a broadcast domain. Each port will have a collision domain and a broadcast domain. Is there any question? Now I have a hub. The hub will never have more than 8 ports because they don't have much collision domain. So let's say I have 8 port. That's the maximum according to the standard in the world you will have. Hub will not have more than 8 port. You may have 4 ports, 6 ports, maximum of 8 port. Now you have an 8 port hub. To all the ports, devices are connected. How many collision domain, how many broadcast domain we have? That's the question.
Okay. Only one, sir. One collision domain, one broadcast.
There is only one collision domain and one broadcast domain. Perfect answer. Now, I have another hub port. Devices are connected. And I got a router in between. Now how many collision domain, how many broadcast domain?
Okay. Hub is always one collision domain, one broadcast domain, and even router also is the same. Router depends on the port. I have two ports is there, so two broadcast domain and one collision domain.
So what is the total number of collision domain and broadcast domain?
Okay. Total. Four collision domain, 3 broadcast domain.
Okay. Actual answer is 2 collision domain and 2 broadcast domain in total. I am going to explain you.
Okay.
You see, what do we call as broadcast? When a packet is sent, it will be forwarded to everyone. It comes up to here, right? So this is one broadcast domain. It's not like this one and this one. No. This link is connected right here. It ends up to here. So this is one broadcast domain, and collision domain also, when you connect this, the backbone connects to the router. So it becomes shared collision domain and shared broadcast domain. So up to here, it is going to be one collision domain, one broadcast domain. It is not getting, it's not like 1 plus 1. The reason is the moment you connect the hub port to the router, the collision domain of the hub gets extended up to here. Broadcast domain of the hub gets extended up to here. And this is another collision domain and another broadcast domain. So totally you got 2 collision domain, 2 broadcast domain. Okay, it is not been separated in the middle. Is anyone there to stop the broadcast or collision? No, there's no one in the middle. So you cannot add 1 plus 1. If the broadcast is happening, it is stopped only here. If you don't have a router, then it is stopped within. When you have a router, it gets extended and gets stopped here. So it is one collision domain. You understood?
Okay, sir, got it.
Now I'm going to change slightly different question now. Here instead of hub, I have 24 port switch. Now how many collision domain and how many broadcast domain we have in total? See, left hand side we have hub, right hand side we have switch.
Okay. So total. Um, so two collision domain, two broadcast domain.
See, this is switch.
Switch. Even switch also will send only one collision domain.
No.
Route.
No. Switches. What do we learn here? Switches. Left hand side, you see. Each port has got one
Okay.
collision domain, but the broadcast domain in total it is one. So now
Okay.
the collision domain of the switch is 24 because this 24 the port is connected here. So
Okay.
this is 24 plus this one is
Plus
1,
one.
25 collision domain. And the broadcast domain, as you said, it is only 2.
Okay.
This is one broadcast domain, this is another broadcast domain, so totally 2. So we got 25 collision domain this time.
Okay.
And 21 in the left, 24 in the right. This is a very important fundamental. The knowledge that you have got today is very important knowledge for building up your networking job, networking future. Networking, I do not want to use the word carrier, tiffin box and all. Networking future. So we will go into another topic in our next class. Better you go through this one today, revise this and come, especially more focus to be on collision domain and broadcast domain. Yeah.